multiplying polynomials. If you haven't seen it yet, you'll see it in biology. These with these squares. Y'all done that yet? Finding squares. Use it with what? Genes, X and Y, or chromosomes. All right. So when we are multiplying polynomials, the first thing we're going to look at is if you just have a monomial times a larger polynomial. You've seen this before. It is the same thing as distributing, which is this whole row here. So when we distribute, we are multiplying the coefficients. And just like when what we learned with our exponent rules, you're adding the exponents together. So if we have 2x to the third times x to the third, that's going to give me 2x to the sixth. We add the 3 and the 3. Then we just do that for each term. So 2x to the third times 3x squared. 2 times 3 is 6. X to the third and x to the second. Add those exponents, 2 and 3. We get x to the fifth. Go to the third term. 2x to the third times negative 2x. So 2 times negative 2 gives us negative 4. X to the third times x to the first. Add the 3 and the 1, and we get x to the fourth. And then the last term, 2x to the third times 5. 5 times 2 gives you 10. And you still have that x to the third. So all it is distributing if you have a monomial times a larger polynomial. And I probably should have put that example third in this list because that's the longest example here. Next one's a lot shorter. So anytime I'm just distributing, there's that glare. Just distributing a variable, x to the first power. All it's going to do is it's going to make all the exponents go up by 1. Because x times 7x squared just gives me 7x to the third. And then x times 4, we just get 4x. And then same thing with that last one. We're just distributing x to the first. So all that's going to happen is the exponents are going to go up by 1. And then that 9 will have an x on it. So x times 2x squared gives me 2x to the third. X times negative 3x gives you negative 3x squared. And then last, x times 9, 9x. Okay, you with that so far? Because we've already distributed before.
Why are they squared?
When you multiply, you add your exponents. So x to the first times x to the first, 1 plus 1 gives you 2. So we're just going through adding the exponents and multiplying the coefficients. All right, so now we're going to go down to a binomial times a binomial. And the method we're going to use is the box method, or the table method you might see it called. So we got x minus 4 times 3x plus 2. What we're going to do is on each side of this box, we are going to write each one of those. It doesn't matter which one you put across the top and which one you put down the side. It'll all work out. So at the top, I'm going to put x minus 4, so x and negative 4. Down the side, I'm going to put 3x and 2. And we are multiplying to fill in the boxes. So this first box here is 3x times x. So that's going to give us 3x squared. Your next box, 3x times negative 4, gives you negative 12x. Here we go to the bottom row. What is 2 times x? 2x. And 2 times negative 4? Negative 8. Good. All right. So the box is filled in. We've got to write out our final answer. That always involves combining like terms. Typically, these two at an angle like this are going to be like terms. And this is where these get missed. A lot of times people do the box perfect. But now when we're combining like terms, do I add exponents anymore? No. We're just adding and subtracting at this point. So 3x squared, if I combine these two, negative 12x plus 2x, I get negative 10x. And then last, minus 8. So there's our final answer. And you won't always have like terms. Probably 90% of the time you'll have like terms to combine, but not always. It can happen where you don't. All right, same thing on the next one. A plus 3, and down the side, 2a and 1. Okay, so what is 2a times a? Yep, 2a to the second. 2a times 3? 6a, yep. And times 1 makes it very easy. 1 times a is 1a, 1 times 3 is 3. So here's our like terms. So we got 2a squared first, 6a plus 1a. Leaves us with 7a, and then last, plus 3. Okay, and then one more like that. So we got 4n minus 1, and then n plus 5. So for your first box there, what would 4n times n be? 4n to the second, good. And then if I have n times negative 1, it's negative 1n. Bottom row, what's this box? 5 times 4n. 20n. And then last, 5 times negative 1. Negative 5. So there's our like terms. You got 4n squared first, 20n minus 1n, 19n, and then minus 5 last. All right, we good with those? All right, so if we move over to the right side, all that happens when you get bigger polynomials is you make a bigger box. The rest of it does not change. All right, and we're just going to look at those top two. So these two you can go ahead and cross out. Now this is showing you it does not matter which direction you write your box. If you want to make it taller than it is longer, that's fine. All that matters is we have the correct number of squares there. So this is a trinomial, 3 terms times 2 terms. So we need a box that is 3 by 2. Doesn't matter if it goes this way or that way. I'm in the habit of always drawing them this way, so you're probably going to see me do that most often. But either way, it works. So we write these on the correct side. So the 3 term needs to go down this side. So b squared, 6b, and minus 7. And then across the top, 3b minus 4. When you have these, usually you're going to have 2 sets of like terms at the end that combine. Okay, so what would our first box be? 3b times b squared. 3b to the third, perfect. Negative 4 times b squared. Negative 4b squared, right? And then 6b times 3b, what would that give us? 18b squared. Yeah, 1 plus 1. Bless you. Next box, 6b times negative 4. Should give you negative 24b. And bottom left, negative 7 times 3b. Good. And then the last one, negative 7 times negative 4. Negative times a negative. Positive 28. All right, so the box is filled in. Like I said a minute ago, usually on these you have 2 sets of like terms. So write down that first one, 3b to the third. Here's the first set of like terms. These are both b squared. So 18 minus 4. What's that going to give us? 14. So 14b squared. And then for the b to the first power, you have negative 24 and negative 21. What do those combine to be? Negative 45, yes. And then last, the plus 28. So usually that first box and the last box just get brought down. And then you'll have some like terms to combine. Okay, so let's do one more like that over to the right there. You got x squared, 2x, and 1. And then x plus 2. So first box, top left there, x times x squared. X to the third, good. Then we got x times 2x. 2x squared, good. X times 1, just going to give you 1x. I'm going to go into this box because 1 makes it easy. 2 times 1, which gives you 2. Here we got 2 times x squared, which will give you 2x squared. And then what's this one? 2 times 2x, 4x. Good. So here's our like terms. They're always at a diagonal on these like that. So first term is x to the third. For the x squared, we got 2 plus 2. 2x squared plus 2x squared. 4x squared. Yeah. And then 4x plus 1x. 5x. And then plus 2. Perfect. Okay, so it doesn't matter how big the polynomial gets, just make a bigger box. Usually and I'll do the same this year. On this test, every year I'll make a bonus question that it's just a gigantic box. I'll make it like a 5 by 5. See if you can do it. Because it doesn't make it harder. You still just multiply to fill in the boxes. It just makes more like terms to combine. All right, last thing we're going to look at, and I always will show this to you. Usually only have like 1 or 2 people every year that like this method. It's just a different method for doing a 2 by 2. Okay, it's called FOIL. It only works with 2 binomials. It won't work with trinomials involved. It has to be a 2 by 2. Okay, what FOIL stands for is first, outer, inner, last. Usually people like this less because it's not as visual as a box is. Box is very visual, easy to separate things with the lines. Okay, so first just means multiply the first terms in the parentheses. Outer means multiply the outside numbers in the parentheses. Inner, inside numbers, and then last, the last numbers in parentheses. So I'll show you how it works. I'll show you that you'll get the same method if you use the box. And then I will leave it up to you if you ever want to use FOIL again. If you don't like it, you want to stick with the box, that is fine. So if we follow FOIL, first terms, 3a times a. That would give us 3a squared. Bless you. The O, outer, so that would be 3a times negative 2. That gives you negative 6a. The I is inner. It's the middle 2. 4 times a. 4a. And then the L stands for last. So the last numbers are 4 times negative 2, which gives us negative 8. Okay, now when you do FOIL, your like terms to combine are going to be these 2 right in the middle. So negative 6a plus 4a gives me negative 2a. So there's our answer. What you're really doing there is the box without the box drawn for you. That's all FOIL really is. It's just a different method. So just to show you, I'm going to use this space, so forget that problem. If we'd use the box, we'd get the exact same thing. So 3a plus 4, a minus 2. So 3a times a would have been 3a squared, same thing we got there. 4 times a, 4a, same thing we got there. 3a times negative 2, negative 6a, that's what we got there. And last 4 times negative 2. Same thing. And here's your like terms again. So it is completely up to you. If you like FOIL, and you want to use that for all the ones that are 2 by 2, binomial times a binomial, go for it. If you don't like it, you can forget we even talked about it. That's fine. Make sense? You don't have to. Now, FOIL will not work on the 3 by 2s. Okay, there's a third method we don't even talk about because it gets really messy. It's like lining it up and doing old school multiplication. Remember that where you like, I don't even write it out for you. It would confuse some of y'all. Trust me, it's messier.
And does it matter if, like, with this 3 by 3, does it matter if you're doing it up and down or sideways?
Doesn't matter. Yeah. If I want to go, if you like this more, go for it. If you like that more, do that. It's completely up to you. You got any questions there? All right, so what we're going to do, I'm going to make the back side the homework. Now, notice, zoom out here. Some of these, like down here at the bottom, say use the FOIL method. If you want to keep using the box, that's fine. If you don't like foil. Okay, so it's completely up to you. And the last thing I wanted to show you is, because there's always some people that are like this. They struggle they're really good at the box because it's visual, and they struggle at just where you have to distribute, like 1, 2, and 3 are. If you're like that, doesn't it focus? So if you struggle where you just have to distribute and you go with the box, you can make a box out of this. It's just a 1 by 3. You can do that. I have some every year that like to do that. Kind of makes it more visual as how to distribute. Does that make sense? So 4y times negative y to the third would give us negative 4y to the fourth. 4y times negative 2y, negative 8y squared, and 4y times negative 1, negative 4y. And when you only have a 1 by 2 or 1 by 3, there's no like terms to combine. That's your answer. So if you want to draw yourself a 1-row box for the problems that are just distributing, go for it. Good with that? All right, so we got about 15 minutes. You can use that to start this. And just remember, if you don't want to use the FOIL method down here, that's fine. You want to stick with the box. Or, I should say this too, if you really like the FOIL method, where it says use the box method on these 2x2s on 4, 5, and 6, you can use FOIL if you want. The method's completely up to you. Yeah.